Thank you, everyone, for coming to this talk. My name is Sunitha Kambhampati. I'm a senior software engineer at IBM. I work at IBM's lab for Center for Open Source Data and AI Technologies. Our team consists of open source developers. We work on different open source projects in the enterprise AI lifecycle. The goal for our team is to make it easier to create, deploy, and manage AI solutions in the enterprise. And we're located in San Francisco. Today, I will introduce a Spark Extension Points API as a way to extend Spark. And then we'll do a deep dive into the details on what you can do with this API, how to use this API, and some of the things that you need to be aware of in using this API. And then I'll talk about some of the enhancements that we've proposed for this API, the motivation behind it, and also the performance results that we're seeing. So first, let's look at some of the use cases for why you want to extend Spark. So the first use case I want to mention is for performance benefits. So in our case, we wanted to add support for informational RI constraints in order to improve the query performance. When you have data that supports RI constraints, there are certain query optimizations that we can do to improve the performance. So that was one use case. In order to do that, we would have to add support to create the constraints and also to add the optimizations in Spark's optimizer. So the second use case is also for performance. It's to add data skipping indexes. The third use case I want to mention is to enable functionality. This is a case where you have your application, it uses Spark, but then the bulk of the logic is probably outside Spark. But for your application to work, you probably need a little bit of changes in Spark itself, or maybe it's just some hooks in the optimizer or in the DDL or something like that. So in all of these cases, you have a need to extend Spark, you have a need to add customizations. So you have developed your customizations to Spark. Now, how do you go about adding it to your Spark cluster? So some possible solutions are, the first one is maybe you can get your code merged to Apache Spark. But there are challenges associated with it. Maybe your code is application specific, or maybe it's a value add, so something that you don't want to open source, or something that's not generic enough that the community might accept it. So the next option is maybe you can modify your Spark code. You fork the branch, and then you put in your optimizations, and you use it. But the challenge to that is there is a maintenance overhead associated with that. So an extensible solution is actually to use Spark's Extension Points API. It's a great API that you can use to add your customizations. So this API was added in Spark 2.2, in Spark 18127. It's a pluggable and extensible API. It allows you to extend Spark session with custom optimizations. It is marked as an experimental API, but it's relatively been stable. It hasn't really seen many changes to it. The original API stays as is. There have been some additional customizations that have been added recently. So now let's look briefly at the query execution phases in Spark before we look at what customizations you can do. Catalyst is Spark's optimizer, and in Catalyst you have trees. Catalyst has classes to represent trees and rules to transform your trees. So basically, when you have your SQL query, you're trying to execute your SQL query, the parser will parse the SQL query and then create a parse logical plan, which is an abstract syntax tree. It's also called an unresolved logical plan. The reason it's called unresolved is because the relation and the attributes are not resolved yet. So then it goes through the analyzer. The analyzer will try to run a bunch of rules, and it'll try to resolve your plan. So it'll look up the relation in the catalog. It'll try to figure out the attributes, the types of the attributes, and the types of the expression. And basically, what the analyzer does is it has a couple of rules. And the rules are nothing but functions that let you transform a plan from one plan to another plan. And these rules in the analyzer are grouped into batches. And a batch is a special term in Catalyst. And basically, there are two types of batches. You can group rules in a fixed point batch. That means that the rules will run up to a fixed point or up to a max number of iterations. And then the other batch is that runs only one time. So there's a batch that can run only once. So in the analyzer, these rules get run, and then from the unresolved logical plan, it will resolve all the references, and then you have an analyzed logical plan. So going further, what you have is, so at the end of analysis phase, you have the analyzed logical plan, then it goes through the optimizer. The optimizer also works on rules, so you have query rewrite rules in the optimizer. What it does is it takes a query plan, and it will generate semantically equivalent query plan for better performance. So you have rules like column pruning, you have predicate pushdown, you have constant folding, and lots of different query rewrite rules in the optimizer. So once the optimizer runs through all the rules, then you have an optimized logical plan. So once you have the optimized logical plan, then it goes through the physical planning stage. Spark Planner is a physical planner in Spark, so it will run through a bunch of Spark strategy, which are some rules which will convert your logical plan into one or more Spark plan, which is a physical plan. And the physical plan will have, it'll have nodes that are physical operators that match Spark's execution engine. So that's a brief overview of the different phases of your query execution. Now let's look at what customizations are supported. So in here, you can see you can have parser extensions using this API. So you can inject some parser extensions in the parser layer. Then there's rules that you can add to the analyzer. There are rules, custom rules that you can add to the optimizer. And there are also custom Spark strategy that you can add to the Spark planner. So at a high level in terms of the code, there are two main things that you should be aware of. There is a new class called Spark Session Extensions class. And this class has member variables to hold your customizations for you that you pass to Spark. And there are methods that you would use to pass your customization. And then the second thing is there is a new method called with extensions in Spark Session Builder that you will use to pass your customizations to Spark. So in here, I'm showing the class structure of Spark Session Extensions. Basically, broadly, there are two types of methods in here. There are inject methods, and there are build methods. So the inject methods are the methods that you would use to pass your custom user rules to Spark. And the build methods are the methods that Spark will use internally to pass it to the different components of Spark. And it is a developer API, and it is marked experimental. So the inject methods are the important ones that you should be aware of when you're trying to use extension points. So here I'm showing the different methods. So there's the inject parser that you can use to inject extensions in the parser layer. There is the inject resolution rule, inject check rule, and inject post hoc resolution rule. These three will get used if you want to customize anything in the analyzer. The inject optimizer rule is used to inject rules into the optimizer. And inject planner strategy is what you would use to inject Spark strategy to Spark planner. Recently, in the master code line, there's a new functionality to inject a function. So basically, it will register a function in the session catalog. So this is new, and it will be available in the next release of Spark. So how do we pass our rules to Spark session and create our custom Spark session? So there are two ways that you can go about doing this. The first one is there's a with extensions method in Spark Session Builder. What this method takes is it takes a function. The function takes one argument, which is your Spark session extensions. And in your function, you will call whatever inject method that you need to inject your rules into whichever component that you want to inject into. And the second way that you can do this is using the Spark configuration parameter. It's called Spark SQL extensions. And what this parameter takes is it takes a class name that implements a function that basically would take your Spark session extensions and call the appropriate inject methods on it. So now that we have looked at a high level what this API is all about, next we'll do a deep dive. I'll go over each of the different customizations with an example and what you would need to do to use this API. And you will notice that the pattern is very simple. There are three steps that are common across. So the first step is you would write your customization. The second is you would write your wrapper function. And the third is you would plug in your wrapper function into your Spark session. So the first use case I want to mention is you want to add your own optimization rule to Spark's Catalyst Optimizer. So for our use case, it was we wanted to add this optimization for RI constraints called GroupBy pushdown. So what you would need to do for that is the first step is you have to implement your optimizer rule. So here I have my GroupBy pushdown rule. It takes a logical plan, it does whatever transformation I need to do, and then it returns a logical plan. So these are called pattern matching functions. They are partial functions. So depending on whatever logic customization that you want to do, you would write your logic in here, and you would basically extend the logical plan, the rule logical plan. And the second step is you would create your extensions builder function. And that's basically a function that's taking your Spark session extensions and then calling the appropriate inject method. So in here, I'm calling the inject optimizer rule, and then I push the GroupBy pushdown into this method. And the third step is you would have to pass this customization to Spark, so you would use the with extensions method in Spark Session Builder to create your custom Spark session. And once you've done this, when you run your queries, your optimizer actually has your rule already injected, so it will kick in. So now that was from the user level, right? So now how did this rule get added from a code perspective? So the Catalyst Optimizer has rules. They're grouped in batches. There's one fixed batch which has a placeholder to add your custom optimizer rules. And this method is called extended operator optimization rules. And what it takes is it takes a sequence of rules that it will pass to this batch. So when you pass your customizations to a Spark session, it's storing your customizations in this class variable called extensions. And when you create your Spark session, there is a session state that gets created. As part of that, it will instantiate a new Spark Optimizer instance in which it will override that placeholder method, which is the extended operator optimization rules. And it will pass the custom rules in there. And that's how it works under the covers. That's how the rule went from your Spark session extensions to the optimizer. So if you want to look at the code, you should check out the optimizer method in base session state builder. So some things to note. The rule gets added to a predefined batch. So you don't have control over where the rule gets added. Sorry. So the batch here is, again, the rule executor batch. It's a special term in the Catalyst Optimizer. So in the master trunk, today, if you had to do the inject optimizer rule, it will get added to the following batches: the operator optimization before inferring filters and operator optimization after inferring filters. So if you're trying to do this for a released version of Spark, it would be good to check the optimizer class to see where that placeholder method is being called and which batch it's getting added. But in general, it is to the operator optimization batch that exists today. So you can check out the default batches method in optimizer class. So the next use case I want to talk about is you might want to add some parser extensions. So for us, it was to add RI support. So we wanted to add DDL statements to support creation of these RI constraints. So in order to do this, there are 3 steps again. So the first step is you would implement your parser customization. So in this case, I have my RI extensions parser that extends the parser interface. The thing to note here is it takes in 2 arguments. There's a Spark session, and then it takes in a delegate. So you can deal with whatever new DDL that you wanted to parse, but then you can delegate to Spark SQL parser for the rest of the SQL syntax. So the second step is you would create your extensions builder, and you would use the inject parser to pass your RI extensions parser. And then you would use the with extensions method to create your custom Spark session. So how did the parser extensions work? So the key here is there's in the Spark session, there's SQL parser, which will get created by calling this build parser on the extensions object. So you can take a look at the base session state builder class and look for the SQL parser. And then the Spark SQL parser is the default Spark parser, and this gets passed in to your customization class. So you would need to make sure that either your parser can take care of all the parsing, or you would have to delegate to the passed-in Spark SQL parser. So the next use case I want to talk about is to add some specific checks in the analyzer. So for this, again, it was our RI use case. So we had some new DDL, and then we had some logical plan nodes that we wanted to then do some checks in the analyzer. So in the analyzer, there are three customizations that you can do. There is the analyzer rules. For that, you would use the inject resolution rule. The post-hoc resolution rule, you would use, to add any post-hoc resolution rule, you would use the inject post-hoc resolution rule. And to do any check rules, you would use the inject check rule. So I have this rule, my RI rule. To add it, so first I implemented my analyzer rule. It takes a logical plan and returns a logical plan. And then I want to add it to the resolution batch. And so I use the inject resolution rule. And then you would call the with extensions method to create your custom Spark session. So how did this rule get added to the analyzer? So the analyzer, again, has rules and batches. And in this case, it has one batch, which is a resolution batch. And that has a placeholder called extended resolution rules. And this is a placeholder through which it will inject all your custom rules. There's another batch called the post-hoc resolution batch for post-hoc resolution rules. And this batch will only run one time. The resolution rule actually is a fixed point batch. So similar to the earlier case where we saw, so the extensions get stored in Spark session. And when you customize your Spark session as part of the Spark session creation, the analyzer is created by overriding these three variables, which is extended resolution rules, post-hoc resolution rules, and extended check rules. So you might want to check the base session state builders analyzer method. And if you're using the Hive external catalog, you might want to check the Hive session state builders analyzer method. So some things to note is even here, there is a predefined place where your rule gets added. You cannot just add anywhere you want in the analyzer. Your custom resolution rule goes to your resolution batch. Your check rules are something that happens after the analysis is done. It will call after all the Spark checks are done. So next, let's look at adding custom planning strategies. So in this case, it was for adding indexes. And so we have a new index strategy that we wanted to add. So you first implement your new physical plan strategy class. This is a little different from the previous ones that we saw because this is it will take a logical plan and return a physical plan. So there's a Spark plan. So your index strategy extends Spark strategy, and then it takes a logical plan and it will return a sequence of a Spark plan. So you would create your extensions builder function. You would call the inject planner strategy, and then you would call the with extensions method to pass this customization to Spark. So how does this strategy get added? So Spark Planner is the physical planner in Spark. It uses a sequence of Spark strategy. There's a function called strategies function, and it has a placeholder called extra planning strategies. So whatever customizations that you added will get added as part of the session state creation. It basically will create a new Spark Planner instance, and it'll override the extra planning strategies to include your custom strategy. So the two classes that you would want to look at is, again, the base session state builders planner method and the Hive session state builders planner method. So some things to note in this case is your custom strategies will be tried after the strategies that are defined in experimental methods and before the regular strategies. You might want to look at the Spark Planner strategies method. So the next use case is, this is new to Spark. It's not released yet, so in the next version of Spark, you should be able to register custom functions in the session catalog. So we'll see an example of how to register a custom function. You would create a function description with your custom function. So in here, I have a function where it's trying to find the length of a string in UTF-8. So you would create your function description, and then you would use the extensions builder function where you call the inject function to inject your function. And then you would call the with extensions method to pass your extensions builder method. So how did the custom function registration work? So all of your injected functions are stored in Spark session extensions. And when your session catalog is created, the injected functions are registered in the function registry. The base session state builders function registry is something that you can take a look at if you want to look at the code. And the simple function registries register function is something that is useful as well. So some things to note here. The function registration order is same as the order in which you inject your functions. So in the order in which you call the inject function, there's no check that happens if an existing function already exists in the session catalog. So it will just replace, if you do an inject function, it'll replace the existing function. But there'll be a warning that is raised at the time when it's trying to register the function. So you can use Spark session catalog's list functions to look up your newly registered function. One thing to note is the functions that are registered will be temporary functions. And the method that you would want to look at is a simple function registry.register function. So I finished going through all of the different supported customizations using this API. But there are some cases where you might want to maybe exclude an optimizer rule because your new rule is probably in conflict, or maybe you want to replace it. So in that case, Spark 2.4 has this new SQL configuration called Spark SQL optimizer.excluded rules. And what this configuration parameter takes is, it takes a comma delimited class names of the rules that you want to exclude. So if you want to exclude a rule and add your rule, you can use this. Or if you want to exclude your rule, you can use this as well. Next, I want to talk about some of the other ways that you can customize Spark. So before the extension points API was introduced, there is this experimental methods class that lets you customize two things. You can customize the optimizer rules, and you can customize the physical planning strategies. So the way you would go about doing this is the Spark session has an experimental method that gives you a handle to the experimental methods object. And you would call the spark.experimental.extra optimizations to pass any optimizer rules to Spark. And if you want to add any physical Spark strategy, you would use Spark experimental.extra strategies to pass any of your Spark strategies. So one thing to note here is the location where this gets added is slightly different than the extension points API. So the extra strategies will get added in the beginning of the strategies in Spark Planner. And for the optimizer rules, it gets added after all the batches in the Spark Optimizer. So use the experimental methods only if it is advantageous for your use case. Otherwise, the recommendation is to use the extension points API. So next, as I've been talking about all the steps to do to add your customizations, you can see that there's specific places that it gets injected. There's no control over where to inject your rule. So in our use cases, we have seen that we needed a way to inject an optimizer rule in a specific place. And so we have proposed some API enhancements. I have opened the Spark Jira, and there's also a PR with the code, so you can try that out. So the motivation behind it was to add control over where a rule gets added, and also to give the ability to add batches in a specific order. So what this API enhancement is basically to add support for injecting the optimizer rule in a specific order and injecting an optimizer batch. So the first API is to inject optimizer rule in order. And it's very similar to the inject optimizer rule, except now you have the way to specify the order where you want the rule to be injected. You can specify the rule name before or after which you want it to be injected, and the batch where you want it to go to. And the second API is the inject optimizer batch. And this lets you inject a batch of optimizer rules, and you can specify the order where you want to inject the batch. So in here, it takes a batch name. You can specify a fixed point up to how much it should run, and then you can specify to after which batch or before which batch it needs to be added, and you can specify all the rules in this batch that you want to inject. Now we are done with the deep dive part of the talk. Now I want to talk about an end-to-end use case where we used one of the optimization that we developed for RI, and we used the extension points API, and we ran some performance numbers. So the GroupBy pushdown through join is an optimization that we implemented for the RI feature work. Now what this optimization does is basically it pushes a GroupBy below a join. And the rationale behind it is to reduce the number of rows that will be input to the join so that it will improve the execution time. And in general, you would probably use cost estimates to figure this out. But when it is an RI join, and under certain conditions, you can heuristically push down the group below a join. So in that case, the input to the GroupBy would remain the same before and after the join. And the input to your join is reduced, and this gives us an overall reduction of the execution time. So in this picture, I don't know if it's easy to see, but basically it's a query from TPCDS benchmark. It's a modified TPCDS benchmark query. It has aggregate functions, so on fact table columns. It has grouping columns. The grouping columns is a superset of all the join columns. It has a PKFK join. So in here, there's join between 4 tables. Store sales is the fact table, and then date dim, customer, and store are the dimension tables. So as long as there are no predicates on the dimension table, we can actually push down. We can push down the group below the join. So in this case, we're able to push this group below the join for the customer and store with store sales. But in case of date dim, we are not able to push it down because there are predicates on the date dim table. So I show a query here. So basically, it is, again, a TPCDS benchmark query. It's slightly modified, query 29. What this query is doing is it's retrieving the minimum quantity of items that were sold between the year 2000 and 2002, grouped by customer and store information. There is a star schema. So store sales is my fact table, and then I have the dimension tables. And in here, this plan on the left is before the transformation, and the plan on the right is after the transformation. So you can see that the hash aggregate, which is the group, that gets pushed down below the join. And the number of rows that were input to the join was 1.6 billion before the transformation. And with the transformation, it's about 153 million. So we've run our tests against the TPCDS 1 terabyte benchmark. And for this query, we're seeing about 2x improvement. So here I'm showing the output of an explain in Spark for the same query that we just saw before. And you can see that the aggregate is actually pushed down below the join for the customer and store sales. So the way that you would get this query is if you do explain extended, or if you're using the API, you would say explain true in order to get all the different phases of the query plan. Otherwise, when you just do explain, you only get the physical plan. So in short, so what we did is we implemented our RI constraint feature. We implemented this new optimization rule. We used our optimizer customization. We used the inject method, the new one that I just described, the inject optimizer rule in order, and we've achieved 2x performance improvements. So to recap, to extend Spark, use the extension points API. It's great. There are 5 extension points that are available today. To add a rule is, in general, a 3-step process. You would implement your rule. You would implement your wrapper function. You would have to use your write inject method, and then you would plug in the wrapper function. And that's how you would end up using the API. So I have some resources here. The first blog is actually to add an optimizer rule. It has a full implementation. And the second one is writing a customized parsers. And then the third one is actually a unit test. The unit test is a great resource. So if you want to find more information, you should check out the unit test that's there in Spark. And then I list out 2 of the JIRAs. So the first JIRA is a JIRA where this extension points API was added. And the second one, which is Spark 26249, is the one where I'm adding the enhancements. So if you have feedback or if you want to try it out, feel free to try it out. I'd love to hear if it solves your use case. And the PR is there. If you need help trying to get the code and try it out in your environment, feel free to ping me on that JIRA. And yeah, I think that's all I had. Thank you. I guess I could take questions.
Let's open up the floor for questions, if you guys can line up at the mics.
Yeah, it's very clear about the process to do the extension. So I have a question. If I extend the Spark, and unfortunately, underneath the implementation, it will introduce a 200 meg a jar. So what's your thought about it? Because it's registered into Spark session. Will this 200 meg jar will be redistributed every session? Or can it be distributed once for all? Or it can be shared, et cetera?
So this is for when you're using the Spark extensions, right?
Right.
So it is similar to how when you do the Spark submit and you pass the jars. So that's how it ends up being the same way, yeah.
Okay, that means this 200 meg jar will be redistributed every time when I submit a job.
Right.
Okay, thanks.
Any other questions?
Hello.
Hi.
Just have a question. What is the difference between injecting a function or using a user-defined function?
Could you repeat it again?
Yes, sure. Can you clarify the difference or the benefit of injecting a function versus using a user-defined function?
Okay. So, so injecting the function, what this is doing is it's registering the function. So if you don't want to use the inject in your Spark session, you would basically call register function. And the only benefit to using the inject is basically if you had, like, let's say, 10 custom functions. So you could just do, you could inject all of them or use the Spark configuration parameter, do it once. And then in your Spark session, you don't have to call the register function.
OK, thank you.
Yeah, sure. So it's just a benefit of not doing the register, yeah.